Hey, pre-calc students. So for this particular set of standards, converting from polar to rectangular and back and forth, what we're doing is we're kind of looking at the battleship lab as well as the one we're already in. So, but they'll both give you lots of standards for this, so that's why we want to kind of combine them together. So on the battleship lab is where you'll find these particular worksheets, but again, we're kind of gonna give you several standards for this. So let's say you've got some ships out in the ocean or something, and this is the polar coordinate system. Okay, it looks a little different. It's measured by angles and radii. Okay, so like if you have a ship that's here, all right, that's on a certain angle, okay, from 0. And it's also, if you look at the radii, like this would be 1 radius, this would be 2, this is 3, distance of 3, and then this is 4. So we're going to look at converting from polar to rectangular. What would it look like if we took the polar coordinates and then converted them back to rectangular, so that the rectangular again looks like this? Okay, so again, we're going to convert for this one. Now it looks like on this particular polar coordinate system, okay, that your angles start here at 0, and then pi over 6, if you remember, was 30 degrees. So that tells me that this mark right here, halfway between, is 15 degrees. And then that also tells me that half of 15 is 7.5. So each of these little marks right here represents 7.5 degrees. Okay? So you'll just have to remember that as you go around. We're going to look at this B right here. This is where one of the parts of the ship is located. So let's look at this B that's right on the top here, figure out where that's located, and then convert it to rectangular. So right now, as far as units out, radius-wise, here's 1, 2, 3, 4. It's on the 4th circle. So R, we have it in polar form, R equals 4. And then theta is actually, remember, 360 degrees is all the way around. And this one is 7.5 degrees less than that. So we take 360 and we subtract 7.5. And we get 352.5 degrees. So there we go right now. That's in polar form. We want to convert that to rectangular form. And remember, this one's actually nice and easy. All you have to do is follow these two things. So if we're trying to find x and y, we just take the radius, r, which is 4, and find the cosine of that angle. And whatever that is, that's going to be our x-coordinate. And then we're going to do the same thing with our y-coordinate. So, except we'll use sine. So I'm just going to put in here 4, x equals r cosine theta, so 4 cosine of 352.5. And then we're going to figure out what that is, and then we'll do the sine. Do the same thing for the sine. So 4, and then cosine, and then this answer right here, 352.5. That gives us about 4, but we'll say 3.9. Oh, it is pretty much about 4, but let's just say again 3.97. So that would be the x-coordinate. Okay, and that makes sense because remember this this point right here, remember it goes right about 4. So it goes right, and it's really close to 4. So it's 3. We said 97. It goes right, and then this next coordinate should be negative. Okay? So now our sine theta, so now we got to do 4 sine of 352.5. Okay? So clear that out. 4 sine of 352.5. We get negative 0.52. So again, this if this represents 1 all the way down on this thing, then it looks like we go right 3.97 and then down about negative 0.52. So those are our coordinates, and if we want to write them as a complex number, we can say minus 0.52i. Because remember, it was a plus bi, so we can write it like that. Okay? So, yeah, so that's the answer for that one. So that's what you're going to be doing. You're going to find all 4 of these, and then we're going to find these as well. But then on this next worksheet, let's say this is your partner's worksheet. Let's say they're working with rectangular coordinates and they need the polar coordinates. Okay, so I was going to actually do the C that's down here. Okay, let's say this is a rectangular coordinate system, right? And this C right here is located at negative 1, 2, 3, negative 4, and then down 2. So negative 4, negative 2. So let's say you need the polar coordinates then for this one. Okay? Negative 4, negative 2. It's down here. So remember, if I draw, the angle to that is going to be this angle. That's actually what we're looking for, theta. But we'll end up finding this little reference angle right here, and we can call it beta. So we'll end up finding beta. So again, start by finding r, if you want to. So what's our radius or our modulus going to be? So we can say modulus is going to be the square root of, and then if we wrote it in complex form, it would be negative 4 minus 2i. This is a, this is b. So this is going to be a negative 4 squared plus a negative 2 squared. And what is that? 4 times 4 is 16. Okay, the negatives end up canceling. So this will be 16 plus 2 times 2 is 4. So 16 plus 4 is 20. So this is the square root of 20. And if you want, you can simplify this. Because 20 equals 4 times 5, I can take the square root of 4 and get a 2. And then I'll just have to leave that 5 underneath the square root. So it'll be 2 root 5 as the simplified form. And then, like I said, the inverse tangent of negative 2 over negative 4, that's going to give us this reference angle right here. And then we'll use that to find, our angle. So again, on here, I'm going to do inverse tangent of negative 2 over negative 4. And I get 26.6 degrees, about. So I did tangent, inverse tangent of negative 2 over negative 4. That was b over a. And I got 26.6 degrees, about. And then I got to just look where it is. So right here, halfway is 180. And this is 26.6 degrees more. So you're going to add 26.6 to 180. And you're going to get 206.6 degrees. Oops, that's supposed to be 6. Okay, so so then you can either, like normally you would see your answer either in r theta, or you might see it in the complex form that we looked at that was a little more complicated. So 2 root 5, comma, 206.6 is one way to see it. It's r theta, but you normally write it in the more formal way, which is 2 root 5 times, and then you say cosine of 206.6 plus I sine of 206.6. Okay, so that would be how you would really want your answers to be in polar form.